plastic, foam, non-ferrous metals, such as aluminum, and brass. You know, you're not going to be machining them like you would on the mill, but you know, you're cutting letters out and you know, stuff like that. Cardboard and vinyl, if you have a drag knife, which we don't have, but I think we're going to get.
Is there a specific type of foam you can use? I mean, does that do
They make special foam for it.
Okay.
But you can also use just like insulation foam.
Okay.
It's a mess because stuff just generates a static and it sticks to everything. But yeah. You can etch glass, but if you're going to etch glass, you may as well do it on the laser because the laser does a much better, quicker, better job. And we do not cut ferrous metals like iron and steel. And I think the reason for that is because they make sparks, and as the sparks go up into the dust system, kaboom. Material thicker than 6 inches, of course, depending on your bit, you know. And do not cut human body parts. There's a bunch of big red switches on the machine. When the machine is running, the space bar will stop it, and your mouse is locked into the only thing you can push is stop when it's running. So just make sure you know all the places to stop the machine if something happens. We already went through this. The machine must not be left unattended. Make sure everything is tight. You know, make sure your bit's in tight and whatnot. Obviously, if you can't hold it, don't cut it. Make sure the path to the machine is clear. You know, sometimes I'll have my box of bits sitting on there and it's like, you know, I'm cutting something over here and the box of bits, no telling them, the thing might come this way, you know, to make a move and knock your thing over, you know. You don't want to knock your beer over while you're obviously no loose clothing. Typical wood shop, you know. Common sense. You know, don't put your hand underneath the bed, you know. Okay, this is our if you can't hold it, don't cut section. We've got a few different ways of attaching stuff to the spoil board. The machine has a bed made out of MDF that is made to be cut into. It's not made to be gouged into, so try not to gouge the hell out of it. But you can't screw stuff down, nail stuff down to the bed. Just try not to thrash the bed as much as possible. We've got a classic nail gun that's got like little nylon nails, like finish nails. And if you got like a piece of material like this, it's great. Or, you know, thin plywood. Softer woods, you know, if you got, you know, 3/4 inch piece of pine, you can use that, but, you know, try and send one of those nails through a piece of oak, it's just going to shatter the nail. So, you know, if you can use the plastic nails, use them. Joe loves the plastic nails, I hardly ever use them. Plastic bolts. There are anchors every 12 inches on the table, threaded anchors. They go through, and if you drill holes in your piece, you can screw it down at the anchors. It works great if your piece is big enough to fit anchors and you can work the anchors into your design. Clamps. Some people use clamps. I don't prefer clamps, but if you do use clamps, try and find plastic clamps because sooner or later the bit's going to hit the clamp, trust me. And if it hits a metal clamp, it's bye-bye bit. If it hits a plastic clamp, bye-bye clamp. But clamps are cheaper than bits. Screws. I screw stuff down a lot. Just make sure, double sure and triple sure, that the screw isn't somewhere where the bit's going to go, because we'll break your bit. And I used to have a bit in my collection that brand new bit. I thought I had it right, and it just cut the tip right off my bit. So just make sure that, you know. And a special jig, I'm going to use a special jig when we go use the machine in a bit. It's great for, you know, if you do the same kind of thing over and over again, you know, you make a jig, And a vacuum table, which we don't have yet, but it's on my list of stuff to do. Okay. Password to the computer on the Shopbot is Boxgill. Before I forget, I've got that written down for you here, along with how to contact me.
Is it possible one of you gentlemen could post whatever you're recording?
Yeah.
It'd be great.
So the computer password over there is Boxgill. It's kind of a private joke because all we do here is make boxes. Yeah. The first one of the day to use it, you need, whoops. Your first one of the day to use the machine, warm it up. There's a warm-up routine, and we'll go through that when I go over there and we'll use it. Always do an XY home before you begin, because when the machine is off, you can move the gantry by hand. So it's quite possible that when it's off, someone moved it. And now it has no idea where it's at. Once it's on, you can't move it. You turn that machine off, you can just move it. So just make sure you give it a good home before. Keep your files on your thumb drive. I can't guarantee that if you leave your files on the desktop of the computer that they won't get erased. And speaking of that, remember to bring your thumb drive back with you. Everybody who's ever used the Shopbot has left their thumb drive in the machine at one time or another. But try to remember to bring your thumb drive back. I'll go over this. You need to hit the reset button after starting the software. When you start up the software, it's going to tell you that a stop button has been hit, which is kind of misleading. So, please don't change default settings. Change something, set it back the way you found it. We can ignore this one because we got rid of that problem. And when a file is cut, it's going to keep a file on your thumb drive where it got the file, the cut file from, with an extension .log, and that's going to tell it the last line it cut, cut time and all that, so that if somehow you need to stop it mid-cut, you know exactly which line to go back to. So if you see files on your thumb drive that you don't know where they came from, it's machine writing a log file, and it'll tell you like what's your last cut. Okay, VCarve works with vectors. Does everyone know what a vector is versus bitmap? Okay, we'll go over that. This is a vector, or it could be made into a vector. Basically, if it could be made into lines and shapes, Shopbot works by using shapes and not photographs. So if it can be, there's a tracing thing in there that you can trace it and make it, bitmaps into vectors. But if it, we're talking the difference between coloring books and photo albums. You can do anything from a coloring book, you can't do anything from a photo album. So yeah, you can do something like that. And no, you can't do something like that. And it's just coincidence that that's a Harley and you can't do the Indian, but you can't do the Harley. I'm an Indian motorcycle. So we work with vectors. Now it's going to create two files. The CRV file is a file that you're going to create with your software, and when you save it, it's going to save it as a CRV file. The SBP files are basically what we refer to as G-code. It's not really G-code, but you could think of it as G-code. And those are the files that you have to output here. So you'll take your CRV file, put it on a thumb drive, bring it in here, and generate your SBP file, and then send it over to the machine. You can import a lot of different formats, because a lot of people like me, I'm better at CorelDRAW than I can use the VCarve software, but I've been using CorelDRAW since like 1990, so I know it like the back of my hand. So if you're a Adobe Illustrator expert or AutoCAD user or Inkscape, you can do it in there and import it in. So we can import Adobe Illustrator. If you want to export Adobe Illustrator, you export it to version 8 or below. It screws up on anything over 8. Just about any machine software like this will mess up on anything over Adobe Illustrator 8. Because 8 is when they put in the different layer stuff, and the software just doesn't know how to interpret Illustrator layers. DXF AutoCAD, you export it to DXF, just be aware that DXF doesn't properly save size information. So it might look fine on your software that you're doing the DXF. You might, like I did a file for someone last week, they gave me it in DXF, comes out as 250 feet long.
Yikes.
And I wanted a sheet of plywood, so I got to figure out exactly which, what percent I need to size it down to. Size it down to like 3.21% or something. EPS PostScript works great. SVG, PDF, obviously PDF with vectors in it, and SketchUp files. I think there's a couple more that it can import, because I did this presentation before the latest version of the software came out. What?
I think if you design a base and then you're going to put artwork on something, so like if you use Fusion 360,
Right.
you can import your material
Right.
over, and then you can overlay your design on that. I don't know if that's.
Yeah, I don't know
accurate, but
what Fusion 360 can export to, but it's got to be able to export to something standard.
yeah, you can export DXFs, STP or STLs.
Yeah.
Like you can do, and then obviously.
But see, if you use a Fusion 360, you can just output the G code from Fusion 360
Yeah,
too, if you know the proper post processor.
Mhm.
If somebody's a novice, what program would you use?
This.
Okay.
Because you've already got it installed, you've already got it, and
Okay.
it'll do most anything you want.
Excellent.
But it's just, some of us are experts in other software, so,
Right.
You can import bitmaps, and then there's an auto trace function, and it'll import just about any bitmap format. And you can import 3D models. It does all kinds of 3D models. You can't actually do 3D both sides because you only get in one axis. You can do two sides, one, and then flip it over, but it's still not going to be true 3D because you can't get in from the sides. But you can do real nice relief cuts. And I hate PowerPoint presentations, so let's go do something fun. CRV files. Yeah, there we go. So when you do your files on your software at home and bring it in here, it's going to do just like that. It's going to say it was done on another machine. You want to unlock it, click OK, and now you're gold. So we're going to do this. I'm going to do it on red PVC, but I put a piece of masking on it so that once it's cut out, I can just spray it with black, so it'll be black and red instead of red and white. We've got a preview. The preview in this software is very good. If it doesn't look good on the preview, it's not going to cut good. It's going to cut exactly like you see. So that's basically it. I can set the colors here. Let's see. It's red. No, that's, no, actually, it's gonna be black.
let's say I designed something in real size, and I want it to be this size, but I want to run a test of it. Is there a way, this program I could just
Yeah.
say, do it?
Oh, yeah.
Okay.
Great center.
Yeah, great.
Okay, there we go. It's going to be red here. Yeah, it's gonna look like that. This gives you 3D, you know, you can twist around and see what it's going to look like. So, to output the cut files, I'm going to rename these. This is going to be I like to name my stuff here, that way if I come back to it, you know, in 6 months or a year, I know what's what by just looking at it. This guy here, this is going to be, and say, tool paths. Let's go up here, this BP files. So here, oops. Let's say. Oops. Okay, this one. Save tool paths. Yes. And then there's should be good. Now let's go over it. Your card won't unlock it.
Excellent.
But we get to be the guinea pigs. So put your card in and
The light came on before you.
and if you take that card out when the machine's going,
Yeah.
the machine will stop.
Huh.
So don't think that, oh, I'm going to go over and use another machine over here, because no. That's something that they haven't figured out.
That's an issue though.
Yeah. They don't listen to me.
Yeah. Because now you gotta stay here, but you can't do anything else because you can't take the card with you.
Right. When we put the
Yeah.
stuff, I don't know. They didn't think that through.
Yeah, they did.
Just like they didn't think through the new exhaust fan for the lasers. They've got an exhaust fan that pulls. That's what I was talking about. I was talking about the jig.
Just stick them somewhere for now.
Very weird though.
What?
So he has a weird method to all of his stuff that he does as far as where he puts his stuff. It's only understood by Carl though.
Don't get me started. What?
It's only understood by Carl, that's the problem.
So you've dealt with him before?
Oh, I know Carl. Yeah, he's gonna help me with some of this stuff.
Can someone go grab me a drill? Okay, so we're going to home it. So we open the computer. What's the password? Fox. And then the Shopbot software is this guy down here. gonna open it and it's gonna say, it's gonna give us an error. See? Remote stop button has been pushed. No, it hasn't. It means when you get this, it means push this blue button. You'll hear a click. Now you're good. And the first thing we want to do is warm it up. So we come over here and make sure that there's either not a bit in there or something's not loose there. That's good. And this is only if you're the first person of the day to use the machine, and I'm pretty sure no one's used this machine today. So we go to cuts, C5 spindle warm-up routine. With that, it says start your spindle. Your spindle, this is your spindle. Okay, this turns the spinning on and off. Hit that, hit OK. Now it's going to run for about 10 minutes at different speeds as you warm up the spindle. While that's doing that, we'll go over to collets. This is a collet nut. This is a collet. This is what holds your bit. We've got different size collets. The ones you'll use most often are 1/4 inch and 1/8 inch. This goes in here, quick single. Okay. Whenever you put a collet in, I blow it out, make sure it's clean. Make sure if there's any grime in here, I'll take it to the air hose and, or a brush or something, just, make sure that I get all the grime off of it. It's very important to keep these clean. If they get clogged up, it's going to mess things up. So, this goes in there, you'll feel it quick. There's only one way it goes. You pass it around and you guys can see what I'm talking about.
That way, right?
Don't be, scared to cut into the MDF, but try not to do something like this where you're cutting way deep. But then again, we understand, shit happens. No one's gonna yell at you or anything, but just try not to cut too deep. When the board gets too messed up, we've got a big 1.5 inch bit we go through and we resurface it until it gets down too low. I think we've probably got maybe one or two more on this. And then we'll put in a new one. But yeah, when it gets, and just so you know, the bed isn't always 100% flat, especially in the summer. Because this is MDF, it absorbs moisture, and it could be like a 1/16 of an inch higher here than there. Or it could be low in the middle or high in the middle. So don't trust that the board is always going to be flat. So if you're doing something that's like, needs to be really accurate, put a scrap down, surface that so you know it's flat, and then put your piece on that. Because you can't guarantee that it's going to be flat all over the table. It's pretty flat now because it's winter and there's not a lot of moisture in the air. But just be aware that that isn't always flat.
Bless you.
I was fine, did a 3-mile run in the woods, I came out, I skated for a half-hour straight.
Cut. Carl thinks he's helping. Everyone can see how this is big. If you cut a lot of signs or, you know, one particular size of something, make a jig. Makes things so much easier. So you use this if you pick the small board, we'll use that if we pick the big board. And now that I realize this, I'll put my cut pile back. For my driving. What? I've got to go in there and
That big thing, you go and research the whole thing.
Yeah,
Yeah.
because it's a 48-inch tabletop.
Yeah.
I mean, it's longer than this can handle, but I don't care. I can just surface all the pieces individually.
Yeah.
So you have to put it in the size of the line or whatever?
well, yeah, but since I'm not starting at the XY and putting it in an offset, so it'll tell it that's when where I want it.
How's you gonna know where it's at?
I'll go over that in a second. Now we're ready to get the bits out. Now, before we begin, we're going to home the machine. So we're going to click this XY button. And it's going to go and find its limit switches and set itself so it knows exactly where its zero is. If you do it this way, you can always get back to where you were.
This is a home.
Yeah. And just for the record, although our XY home position is in this corner, this board is not quite big enough to reach our home. So our home is actually right about there, about a 16th inch or an 1/8 inch over. But these marks are all 2 inches, so you can get it by using the 2-inch marks. Okay, now it knows where it's at. Okay, now what I'm going to do is I'm going to hit this yellow box. This brings up our control box. This allows us to move the machine. It's just like it's laid out here. If you push that one, it's going to go this way. Push this one, it's going to go this way. And then up and down. We can also use the keys on the computer, which the arrow keys are just like you would think, and then Page up and page down is your Z. And if you want to move it fast, you right click on one of the buttons, it goes to jog mode. If you want to move it really fast the other side, you don't want to wait. Okay, so we put it on. Let's put this on loose first. So here's the wrench. Now you'll notice this here. This is our spindle on-off. This turns the spin on and off. Okay? And they're pretty smart. In order for me to change the bit, I need to take this out, and there's no way that spindle can be turned on while I'm changing the bit. Stick this up in there, and when you put your bits in, you don't want to bottom them out. You don't have to bottom them out. You want to get them up in there nice and good. Don't cover up any of your flutes, you know, but don't put them in, you know, like this, you know, don't bottom them out, cover them up your flutes. Just make sure it's in there good. Then I tighten it up, you know, manually. And then this holds the thing still, and then this one tightens it. And then we tighten them down. We don't force them down, just nice and, you know, just a little snug. Don't prove that you're a strong man or anything, because that's actually bad for it, because then it could jam it up in there. You know, just get it in there. Okay. Now, typically, your home position is going to be here, and the piece is going to be there, but since it's in the jig, in the software, I told it where my thing is and where to start. So, in the software, it knows that that's my home position. Okay? Now, we're going to home our Z, which is our up-down, or our pit depth. Now you find a good place to home your bit. Always, if you've got a file or you're going to be using multiple bits, always home in the same place. Okay? Which means pick an area of your board that's not going to be taken away by the, you know. So like I know that like right about in here, it's going to be, you know, pretty solid. Might want to even move down over a little bit more. So if you always home in the exact same spot, and that's due to the table not always being exactly level. Yeah, that looks good. This is how we home it. This is basically a switch. When this hits that, it makes contact, it knows. So we just put that down.
Oh.
And we clamp this on there. Okay, make sure that when this is going to come down, it's going to hit. Okay, then we close this little yellow box. And now we're going to hit the button here that says Z. And it's going to say, hit enter when you're ready. So what I do is hit enter, and then I run over here to make sure. Because sometimes the plate will move on you. And if the plate's not under it, it will keep going. And that's powerful spindle, so it'll go like all the way through your piece. It'll do that twice. You're done.
So now that goes, that's home.
Yep. Yep. And always make sure you take that off and put it away before you go any further. Although it tells you right here, someone, Carl, started it up with this. Okay. So now all we got to do is I'm going to raise it up just a little bit so that I can get the duck boot on it. And we should be good there.
Is that just magnetically clipped or?
Yep, just
Yep.
magnets. Okay, now we're going to open our file. before you open your file, close this yellow box. Okay? If you don't, it will let you open your file and then it will crash on you. The Shopbot software, I didn't say this, is a piece of shit. And sometimes it'll crash, and instead of giving you an error, it will just close the software. Or sometimes it'll just freeze up. So you got, you know, there's little nuances in the software you got to get used to. So you go file, part file load. We're going to go to my thumb drive, and I put that in FBP files. And I want 1/4 inch O flute. So I'm going to double click it. Now if you notice, like any other Windows software, you double click and it opens it. Well, it opens it in this. And then when you get to this part, now you have to hit enter. Makes no sense. Why? But that's how it is. Ask me if the tools and the spindle, yes. Is the Z8 axis 0? Yeah, we just did that. Okay, it's telling me to hit that. Hit OK. If you don't start the spindle and you hit OK, it will go through its motions without the thing spinning. Sound like that. It should sound like it's cutting. It should be squealing. It should be, you know. That sounds like cutting.
What kind of wood is that?
PVC. And that's what we'll be making the time down. PVC cuts great. I was always wood, and then I took the class. I was like, ooh, this PVC is nice. It's doesn't have a brand to it and whatnot. So yeah, it should sound like that when it's cutting. Wood can sound different, but you want it to sound like it's cutting, and not like, you know, you don't want it to sound like it's roll or whatever. Also, when you know you've got your speed right, you look at the chips, okay? The chips should look as much like the loop of your bit as possible. It should be chips, not dust. Chips will be dust. You know, sometimes you don't mind stuff.
Now, if you do see dust, does that mean you need to speed up your feed rate?
But that looks just about right. If you look at the bed, look at the bed right here. This is an old food bed, I mean, old food from plastic.
does a bit normally last just cut that PVC?
Honestly, longer than if you're cutting wood.
That's what I figured.
Here's what I have to say about bits. When you're just learning, it's okay to buy the cheap shit. You know, go on Amazon, buy Chinese bits, whatever. You're gonna break them. You're not gonna know exactly what bits you need or what you want. Once you know what you want, once you get into it, then buy the good stuff. Start buying kits now. Just go to Walmart, spend $50 and get 5 knives, right? And I'm cut. That's what they do. And then they'll go double. Or, you know, you can go out and spend $400 on a good set, like these people's German knives or stuff. They're going to stay sharp for like years. So there is a difference. But when you're just learning, don't bother about getting the expensive bits. Let's get it up high. When you change a bit, make sure you get it up high enough to get the dust boot off.
And what size bit do you have in there now?
That is a 1/4 inch.
And you're changing it to a
1/8.
Usually, you know, you use a bigger bit to hog out the big areas, and then you get a finer bit to do the details.
Does the machine know that you need to change the bit now, or is this when you interrupt the system?
It depends how you output your files. You can output your files with all one file, and then it will stop and have you change the bit. Or you can output it as separate files like I did, which I prefer. I used to do it the other way, but I found that 9 times out of 10, in the middle of the cut, I'll want to make some kind of change. And then I'd have to redo the whole, you know, thing, so. Just from experience, I know that, like, I changed my mind. Okay, so let's get this about back where we were. We were at like 6 in here. And I think we were like 25 and 6. You can change it directly in here. But go to.
Oh, so you know where you stopped it, that you were at the 25 to 6. So you
I know that that's where I zeroed my last one, approximately in that same spot.
Okay.
Which, you know, for something like this.
Close enough, you'll
Yeah.
find yourself.
Yeah, you know, if you're doing something that needs to be really accurate, you want to get the exact same spot that, you know. You know, this is something. You know, this is getting me a free t-shirt, you know, not $100 job, you know. So. Then we hit Z. And it's going to say, click OK when you're ready. And then you run over here and make sure this didn't move out of the way on you.
It's going to hit twice.
Yep.
So if you already did it the first time, why do you have to go back and redo it the second time?
Because it changed a bit.
Oh,
Yeah, because the bit, you're not going to get the bit at the same depth as your last bit.
that's the idea.
Okay, we're ready to go. Sometimes when I do the final cut, I don't put the dust boot on just so I can see what it's doing. And I won't, just so you guys can see it cut. So, another thing you need to know, after you do a bit change, make sure you turn this back on. Because if you open your file with this is off, and you try to start it, the machine's going to freeze up. The software's going to freeze up. And you'll be going, what? Part file load. I'll come over here to my thumb drive. And it's SBP files. And this is the 1/8 inch O flute. I was trying to name my file so I know what bit it is. And, you know, I know this is the sales pocket. Just so you know what it is. Because if you use the default, then you do 5 projects, you're going to lose track of what's what. You hit enter, and say Number 2 in the spindle, yes. Zenith 0, yes. This means push this, always push this, because it will go through its motions without it spinning.
You don't have to relet it, warm back up at all.
The bit dropped in the hole.
What?
The bit dropped in the hole.
Did it?
So, yeah, you can see right here. There's a color change.
Yeah, let's get that.
I got it.
I thought it was found something.
I've done that. I don't know how many times I've done that with the standard hand router, and then we're all tight and the polish down, and it's just not tight enough, and the bit just drops out the bottom.
Let's try this again. Hopefully it doesn't.
The back carpet where I make every mistake possible several times. Because doing it once or twice wasn't enough.
Yeah.
Sometimes things like that happen.
Tighten it? Did anyone see me tighten it?
No.
I might not have tightened it.
I was wondering the same. I don't know that you did. You took the boot off and then you started talking about something, so I don't know that you
I
did.
got distracted. Well, we tightened it this time.
You'll have to re-zero it.
Yeah.
Not that I'm telling you that, I'm saying that
Yeah.
for my own edification.
Because you went back and tested it.
Yeah. Anytime you mess with the bit, loosen the polish, take the polish, and you should probably re-zero.
Let's hope we got it tight this time. those are another different or
Yeah,
black.
do you want 5.5? Which color?
So if you're using one of the smaller pieces, you want to set this to 16 wide, or X is 16, or Y is 5.5. This is 5.5, and this is 0.75 thick. Now PVC,
I'm sorry, that was
0.75 3/4,
And the height of this is?
0.75. PVC is 0.75. When you're dealing with wood, it's not going to be exact.
No, the height.
Yeah,
5.5.
5.5.
Thickness is 0.75.
So 16, 5.5, and 0.75.
Yep.
Sorry. I really was saying
That was me.
millimeters.
16, fuck my.
I feel like I've accomplished it.
Okay, now, we have a choice of where we want to zero our bit. Like when I just did, you can either zero it to the machine bed or zero it to the top of the surface of the material. If you're just cutting pieces out, like you got a sheet of plywood and you're just cutting pieces out, not pockets or anything that, you know, matters on depth, use the machine bed. As long as you don't have to do a bit change and you've got a full sheet of plywood on there, then you can't zero it. Because
But if there's some areas that you want to cut out and others that you just
Yeah.
want channels or
yeah,
something. that
for
you
the most
use-
part, you're gonna zero to the material surface like we did in there.
Okay, so change that to machine bed.
No.
No,
No, to
material surface.
Material surface.
Usually, you're gonna
Okay.
zero to the material surface.
Machine bed, you go all the way through. Done.
Okay. Our XY datum position, our home position, is usually in the lower left corner. Does anyone tell me why you wouldn't want to use that?
Well,
Someone-
that machine, it doesn't line up correctly.
Well, yeah, but okay. Someone gives you a round piece of wood, say carve this.
Oh.
Where's the corner on a round piece of wood?
Yeah, yeah.
You know, so if you got a round piece of wood, you can find the center. Some people zero to the center all the time, you know, because they, you know, draw an X on the board, and but it's up to you. But usually it's here. You know, you might have a piece of wood that's got this corner lobbed off or something, so you know you tell it to zero here. Now, what I did, the mistake I made that I had to come back in here and unlock the thing. Here's our use offset. Because I'm using a jig, I can do this and I can go, okay, now I want to go 21 inches over and 4 inches up. And that's going to be my position. So that's the board, you know, basically you're giving it a fake home position. Some people, most people around here don't do it this way, and I don't understand why. They like to put their piece down and then jog the thing over and like, you know, okay, a little bit more, you know. And I'll show you how to do it that way, but it's much easier just to tell the software where your piece is on the board. But I'm not going to use an offset, just do this. Okay, is everyone all set?
So the offset right now, I don't even touch it.
Yeah. Yeah, yeah, we won't do that. I mean, maybe when we output the cut files, we will. But I'll show you how to zero the other way too. So.
We put the datum back to the bottom left,
Yeah.
right?
Yeah.
Just want to make sure.
Okay. This is your basic software.
So I'm supposed to hit OK then.
Over here on this side, it's all your drawing tools. This is how you make your shapes. You know, configure your shapes, put your text and whatnot. So let's just start out by drawing a bunch of circles. And take the square. Squares. Now, if you're familiar with typical drawing software, Alt, you can constrain it, or hang on. Okay. So I've got circles and squares. So everyone, if you're not following what I'm doing, just please raise your hand or something.
I'm not, where are you pulling this from? Where are you pulling the circle from?
This is circle.
Okay.
The circle tool.
Is that a right click or a left click to draw, bring it?
Left click. So we've got a bunch of shapes here. If an object is selected, it's going to have a pink dot line around it. That means that's your active object. That was selected, that was selected. You can hold Shift and click another one to select multiple objects. Now, we can also select things by dragging a box around it. Now, this is different than most, if you're used to like Adobe Illustrator or Inkscape or CorelDRAW or anything like that. This works differently, okay? You go left to right, it's different than when you go right to left, okay? If you go on this way, it's gonna select all the objects that are completely enclosed by the box. However, if you go right to left, it's going to select anything that's inside or touching. So right now, you can get all those.
Again, I'm really simple.
It took me a while to get.
I would have made it a high key.
Yeah, but this is pretty much standard for CAD software, from what I understand. CAD software works like this. So, but basically, yeah, if you want to, it just has to touch on this one. This side is going to completely enclose.
I must have looked down for a second. How are you pulling those circles down there to begin with?
You just click on the circle and then move your mouse over it and click on your
Keep the
paper.
mouse clicked.
I'm on the circle. Click on the circle.
I'm not sure how your mouse works, mine's a little different.
Now you can.
Oh, you see how I'm going from that way.
And then you can do whatever.
Okay, now say you've got a bunch of objects and you want to group them all together, and you want them to act as a group. You can come over here and hit this group icon or Control G and group it together. Now these all act as a group. So as I move it, they all move. You can tell if something's part of a group because although it has a pink line, it's a pink solid line and not a pink dotted line. See a pink solid line, you know it's a member of a group. Now if you notice, when I click to select, I click a second time, I get these little boxes. Okay? The hollow boxes will let me resize. And if you use the corner, it will keep the ratio the same. So your circles will always be circles. But if you use the side, it'll only go in that dimension. Solid are for rotate. So if I grab a solid box, I can rotate it. Now our Alt key will constrain it. So say I want to make sure this is 9 degrees, it goes in 15-degree increments. I'll hold Alt, that's 15 degrees each time. So now I know that that's 90 degrees.
Can I just tell it to rotate 90 degrees?
Yeah, you can too. There's a rotate tool. Right here. As with most softwares, there's probably 5 different ways to do stuff. But that's your grouping, that's your resizing. And your Alt key pretty much is your constrain key. So if I hold the Alt key and I move, I can only move left and right and up and down. So like, you know, say if I got, you know, this and I wanna, you know, make sure that I keep it on the same plane, you can hold the Alt key down. Shortcut is if you hold the Control key down and drag something, when you let go, it's gonna make a copy. So you use that quite a bit. And you can use, obviously you can use the Control and the Alt together and, you know, make a copy and make sure you get it exactly left or right. Is everyone following along? Okay. See these rulers on the side? If you want to set up guides, or just, you know, for aligning your work, you can just drag a ruler on. You can right click and say, I'm gonna put this at 1 inch. Here, 1 inch, so you just drag one in.
Does anyone have a USB-C charger?
Yes, actually.
I got a USB cable that you can put in
Okay.
my stuff. Unless
You're
I need
far from
to-
luck.
Thank
No one ever uses USB-C, but I thought my phone was gonna die, so I made sure.
Thank you very much.
And, well, I've got a charging block too if you want.
Yeah.
Because like, say like this one, a lot of bits aren't gonna be able to get way up into that corner. And then just something with CNC, you got a round bit, you can't make a square edge. So, you know, you'll find that some fonts work better than others.
Do you mind, so you just clicked on the T, I guess,
Yeah.
for text? Okay, and then type in the text? Okay, cool.
Ooh, that's ugly.
If you guys ever want some cool fonts, most of you probably know, but you can go to like DaFont, DAFONT.com and download them and get them on your computer.
Yeah,
1001 fonts.
I always try to find fonts that don't have really sharp angles. It's hard to get into. M's are hard. There's some letters that are just really difficult to cut. This is Arial bold. Oh, that'll work. For demonstration purposes. Okay, so there's our fonts. Next to the font tool, this little guy here is your leading. So if you click, it'll bring it closer. You shift click, it'll bring it farther apart. Typically you want to shift click to give enough room for the bit to fit in there. So that's this guy here. Now let's bring this one forward a little bit here.
So if you did want to design something in Corel and then bring it over, is it really hard to do?
No,
Okay.
no, it's real simple. The one format that won't import is CorelDRAW though.
Okay.
So you gotta export it to Adobe Illustrator 8 or below, or
And then bring it over.
your EPS is what I usually use. Okay. So we've got our word, now let's center it. These are our center tools here. Let's align it to the center of the board. Of course, this is, I'll move this so that, you know, we can align it to up and down, and we can align it side to side. And then these here are for aligning objects to each other. You can take the software home and play with it. So you can figure a lot of this out. You just need to know where the alignment tool is. And that's this little jobby right here. Okay. So now we got the name there. Let's draw a box around it like we did for the sign that I just cut. So now I could just draw another box in here. There's a handy dandy little thing here in the corner. It's an offset tool. So I want to go in, and let's go 1/2 inch in, and offset. Ta-da! I just made a copy, half-inch in. Is everyone following?
It makes sense.
Okay.
It's just knowing where to click on like that, that's just playing with it.
Okay. So those are your basic tools. You'll see that there's a whole bunch of tools, and if we have time, I'll go through more of the tools, but these are your basic shapes and text. So you do what you want to do. This should get you going. Did you want to see how to import a
Well, if it's pretty straightforward,
Yeah,
like you
file.
said, I think I can get it.
file, import,
Okay.
import vectors, and let's go to the desktop here and the Shopbot classic OneDrive and sample files, vector R, we'll import a cat. And the thing you have to know when you import, it's gonna import everything ungrouped, even if it's grouped in your software.
Okay.
So I import, and before I do anything, I hit Control G to group it, so that I don't actually grab one piece. You know, and then you just. I'm not really a cat person. Hopefully it's not there. So those are our basic tools. Now this side here is our tool paths. This is where the magic happens. Thumbtack that open there. So you draw here, and then when you want to do your cutting, you use this side. And I'm going to go over some basic tool paths. One that you're going to use a lot is your pocket tool path. Okay. Okay, right here, how deep do you want to cut? 0.125. Okay. Question that's usually asked from class is, how deep do you cut with a particular bit? Rule of thumb with wood and plastic and everything but metal and whatnot, the diameter of your bit is how deep you cut. So if you've got a 1/4 inch bit, you know, cut a 1/4 inch deep. Got an 1/8 inch bit, cut an 1/8 inch deep. You know, unless you want to go less, but your maximum should usually be the diameter of your bit. So this is we'll do it with a 1/4 inch bit. I'll show you. So we're going to go 0.125 deep. That's an 1/8 inch. We're going to use the 1/8 inch O flute, which is the bit I used, and I'll go over this in a bit. But that's basically all you need to do for that. Hit calculate. Oh, vector selected. You have to tell it which one you want to cut.
Now, if you were cutting something out and you only wanted that area to be cut out, like a 1/4 inch, but your product was 3/4 inch, would you just set it to do several different passes?
Yes, it'll do that automatically. And I'll show you that in a sec. This is our, after you do a tool path, your preview box is going to come up. You can select like what kind of wood you're using. For some reason, they've got the grain all going vertical. I've got if you're particular about it, I've got a set of 800 different wood styles, 400 in each direction, of any wood you want in high quality. So if you want it, let me know, and I'll give you that file. So basically, we go preview all tool paths. Oops, we want it material color, and that's what it's going to be. And if it doesn't look right in your preview, it's not going to cut right, because this is damn accurate. If it don't look good here, don't expect anything good to come out. This is balls on accurate.
What if you want to invert it?
Yeah,
So
that's next. Okay, so everyone understand what's happening here? And then I usually name these so that if I come back to it in a month, I know what layers what. Okay. Now, let's go back here. What happens if I select this box as well? Okay. I'm going to calculate. Set preview. That's smart enough to know that it wants you to leave this. So if you wanted that to be cut out without the border, you would just select this line. Or I'd make the box a little bit bigger than your piece, just to make sure that it's, everything. But that's how we do what you just asked. Now if you want to go back, you double click on one of your tool paths, it'll open it up again. Now, this here, because we're clearing out a whole lot, we don't want to use the 1/8 inch bit for everything. So right here, there's make sure this show advanced toolpath options is checked. And then it'll allow you to use a larger area clearance tool. This is where you select your 1/8 inch or your 1/4 inch bit. So we'll go over here, plastic, there's a 1/4 inch oak flute. And then it'll make 2 files to toolpaths. So now you'll see here, if I go preview visible toolpath, basically that means preview only the ones that are checked. Our 1/4 inch bit is going to do that. And then our 1/8 inch bit is going to go in and clean up the corners as much as it can. It'll do as much as it can with the big bit. But if the big bit can't get in there, it'll leave that for the small bit. It's smart enough. It's also smart enough to, let's say we want to go 1/2 inch deep on this. Now you'll see here, to set this to 4 passes. Because with an 1/8 inch bit, you're going to have to do 4 passes. Then set that to 2 passes. Because we're using a 1/4 inch bit, and I've got the bit set to do the diameter of the.
Where do you see that it says 4 passes?
Right here, passes.
Oh, okay, there.
Passes 4. So it knows, you don't have to worry of, oh, I'm cutting a 1/2 inch deep, but I can only cut a 1/4 inch. Just put it that you want it to cut 1/2 inch and let the software do the rest.
And that's from your bit settings. That's your
Yes.
tool settings.
Yeah, we'll go through bit settings in a bit. But that's your basic pockets. Is everyone following along? Now let's do a profile toolpath. Basically, this is outlines. This is let's go. ID, original blue. Basically, that's not doing a fill. You're talking lines and fills. Pockets are your fills. Your profiles are lines. And this is the one you would use to cut parts out. Like for example, let's just funky here. say you want to
Oh,
cut out
wow.
like that. So we'll go over here, and we'll use a 1/4 inch O flute. We want to go all the way through because we're going to cut through the material, right? So we're going to go 0.75, but you always want to go a little bit deeper, but not too deep. You don't want to gouge the table, but you want to make sure it's getting all the way through. And the bed's not always exactly accurate. So we usually go about 0.02 further than the materials to make sure that we go all the way through. So that would make this 0.77 deep.
So now you've cut that part out.
Yeah, we'll be
Okay,
cutting
so
it.
you've lost your anchor points. So you have, so it's down, this is anchored. You've just cut this little section out here.
Right.
It's detached.
Oh, yeah, well, I'll go through that in a second.
Sorry.
Now there's a shortcut here. Z or T is always your thickness of your board. So if you got your board set to 0.75, you can put Z plus 0.02, or T for thickness plus 0.02, or you can put in 0.77. That's the same thing as putting in 0.77.
And so will that save that as or understand it as a parameter? So if you later
No.
change your Z,
No.
okay.
Nope. And I've talked to this company about that. Okay. 1/4 inch O flute. Okay, we want to cut on the outside of the line. You know, sometimes you want to cut on the inside, sometimes you want to cut on the outside. You have to just basically make the decision on that. And what do we use, climb or conventional? For conventional materials such as plastic and MDF, plywood sometimes, that's conventional material, use conventional. For hardwoods, like oak, sometimes pine, I use climb. Basically, have all of you used a normal hand router? You know how when you're taught to use a hand router, you always go opposite the direction of the spin? Because you go, you know, with it, it's going to travel along. Well, now that we can hold our piece down, we can do an unconventional, you know, and we can move the direction of the bit.
So it won't let it run away.
Right, it's not going to run away, and it's going to give a cleaner cut sometimes. Like on oak tends to splinter, so it's a more gentle cut.
Going with the grain as
Yeah.
opposed to against
Yeah,
it.
yeah, you're going with the bit instead of against it.
Yeah.
So it's going to be more, it's a more gentle cut. But for stuff like PC, plywood, typically use conventional. What we were taught in class, when I went to the Shopbot class, the teacher said, yeah, pick one, and if the piece you're throwing away looks better than the piece you're keeping, flip it around.
So cut two and make your decision
Right.
based on that.
I mean, if you're going to do something important, you're going to usually do a test piece first. You know, you're going to do a test run first. So. But as a general rule of thumb, conventional materials, use conventional. Climb, if it's, the way I remember it is if something you can climb like a tree, I use climb. So that is going to cut it out. It's going to warn me here that it's going to go all the way through. Yeah, I know. Now, as he was saying, this is going to cause me problems because as it gets to here and it breaks loose, the piece is going to go flying off and whatnot. So what we do in a case like this, on a profile cut where we're cutting a piece out, you use this add tabs, and the default settings are usually pretty good for this. So we're going to edit the tabs. And tabs, and when you put tabs in, always make sure you put them in somewhere that it's going to be easy to break them off or sand them off.
Nice.
You know, don't put them like, you know, over here in the corner like that. You know, put enough, but don't put so many that it's going to take you forever to sand them off. And now you'll see when we calculate tell us that it's gonna go all the way through. We'll reset preview. Preview usable toolpaths. What? And you select the pyramid toolpaths, it's gonna be like wider at the bottom. They work real nice. And you just chisel them off. I just take a chisel, bam, bam, bam.
Clean it up with some sandpaper and you're good.
Yeah. But just, make sure you don't put it like right in there because you can't get it on the belt sander. Usually if you take a chisel while it's still on the table, you can get these almost all the way off perfect, depending on your material. Okay, so those are two basics. Another one that people like to use a lot, let me change the font so that I can. Let's put times. Yeah, that looks good. Okay, another one that people use a lot is called the V. We use a V-bit, which is shit. Where's my V-bit somewhere? So you guys know what a V-bit looks like. So V.
You mind closing the toolbox for me?
Oh, sorry.
Okay.
We don't have to worry about this here. I'm using a 90-degree V-bit, which is pretty, standard. You can buy them for $20 at Home Depot. I'm going to use a 90-degree V-bit, and pretty much I don't have to set anything else on there. They calculate. Okay. Quick and dirty. It's like the guy at the fair who's carving signs. This will take 10 minutes from start to finish, You want to impress people, want to make everybody a sign for Christmas, and you want to do them quick and fast. A lot of people like it. And the way this works, in case you're interested, is depth. It will go as deep as it needs to so that the V hits both of these rails. So this will be obviously not as deep, and this part here will be deeper.
Yeah, when Joe was cutting the big round signs.
Yeah. Joe loves the V-bits.
It does a pretty good job.
It's quick and it looks good.
And it actually squares off the edge.
Yes.
The outer edges of the letters.
Yeah. It's quick and easy, and it works good for some things, but not for others.
Yeah.
Yeah.
I doubt it would work well for that cat over there.
Right. Yeah, exactly. But those are your basic toolpaths that you'll be using. And if we got more time, we'll go through it more in depth. But I want to. We've got an hour. I want to go through bits. Whole bunch of different bits. Your basic bit type is an upcut, okay, which spindle always spins clockwise. So we take an upcut bit. It's going to pull the chips up and out. So as it's spinning, you can see here it's raising my fingers up, pulling the chips up and out and evacuating your chips. So if you're using an upcut bit, you can cut a lot faster. Because if you use a down cut, it's pushing your chips in. So you got to do shallower and you got to go slower and make sure. Sometimes you got to follow it around with an air hose because it's just packing the sawdust into the groove. Now, why would we use an upcut versus a down cut? Okay. Use an upcut bit on plywood, you're going to get what's called tear out, which is going to look like this. It's going to grab the top layer of your ply and pull it up and out, and it's going to look like crap. A down cut was going to look a lot better. That's done with the down cut, that's done with an up cut. So for plywood, you definitely want to do a down cut. What's done quite often is you do one pass with a down cut, change your bit to an up cut. Because down cut, you got to go slow and shallow and it takes forever. So you go like maybe an 1/8 inch cut with a down cut, get it all that done, take your bit out, replace your bit with an up cut. And that way when it goes, if you're cutting all the way through, when it gets down to the bottom, it's taking the bottom layer and pulling it up instead of pushing it out. If you're cutting a lot of plywood, and that's pretty much all you're cutting, you can spend a little bit of extra money and get what's called a compression bit, which is both. So it goes down and it's doing a down cut here and an up cut here. It's 2-in-1. Best of both worlds. But they're more expensive.
What about straight flutes?
Straight flutes, I don't use them much in wood or plastic. But they've got their, you know, like Plex, they work pretty good with Plex. But I found that for plastic, I like the O flutes, which I'll show you O flutes in a bit. So that's an up cut and down cut, and you can see there's an up cut and a down cut. You can kind of see it. It's real small stuff. I had a nice big sample, so I'm gonna throw it away. Okay, we went through V-bits. Then there's ball nose bits, which we use for doing something like that. Want to do artsy fartsy, you know, import a 3D model and do a relief cut, use a ball nose for that. And pass a ball nose around. It's just got kind of a round tip on it. And it's obviously the finer point you got on your ball tip, the finer detail you can get. But I've done a lot of these horse. I'm kind of like the horse stall sign maker. Not by choice, but someone in the neighborhood, his daughter had a horse, and she wanted me to make a sign for the stall. So I made a nice sign with the 3D relief cut of the horse. They liked it. Now everyone that goes to her stable and sees it, and they go, "Oh, where'd you get that?" So they call me and they put their up, and before you know it, I'm cutting horse signs.
Perfect.
And one thing that horse people spend money.
Oh yeah.
Oh,
They
yeah.
spend money. It ain't a cheap hobby.
What kind was this?
Ball nose. That's for doing relief cuts like this. Those are your basic bits. For plastic, if you look in the outside catalog, they got like 200 bits. This is an O flute for plastic because it kind of pulls the chips up and out. I'll pass this around. And like I was saying in there, you can buy cheap bits, but they're not going to last very long. The more you spend, typically, the better they are. The bits you get from Lowe's are pretty good. Lowe's or Home Depot are going to be mid-range bits. I think Lowe's has Bosch, which are pretty good. They'll stay sharp, nice and long. But once you are into it and you're cutting a particular thing a lot, spend the money. Like I just, I cut quite a bit of plywood, so I just bought myself an Onsrod bit. Your best bits are Onsrod or Amana. But this is a compression bit, and here's an upcut bit. $20 for a upcut bit. This is like 40, 45. Actually, I think I spent 50 on it. So it's it's different between a $20 bit and a $50 bit. But this will cut through plywood a lot faster because it's compression. So yeah, your best bits are Onsrod or Amanas. But don't worry about spending the money until you know what bit you're going to actually be using.
So if we wanted to get like a ball nose just to start off with,
Mhm.
to try, what would you recommend? Do you have a list of like companies or something we can go through, or?
On this sheet, on the very bottom, I get all my
There it is.
bits
Okay.
on eBay,
Love eBay.
and the seller Drillman 1 has the lowest prices. He ships usually that day or the next day. Charges $3.75 per order to ship. But like this bit, I think I spent $50, and most other places are charging 70, 75. So he's a little bit lower than list price, and they're not knockoffs. They're legit. The guy's legit. A lot of people use him. If you go on any forums, everyone's like, oh yeah, use him that one. And he's great for the small bits. The 1/8" bits, I get all my 1/8" bits from him. He sells them 5 packs and 10 packs, or you can buy them separate. Like this here, that's $35 for 10 bits. So it's like $3.50 a bit. It's cheap and they're good. They're Kyocera. They're real good bits. Yeah, they're real good bits, and they're not, they're almost disposable at $3 a piece. So if I break one or it goes dull, I don't care. It's $3.50. So I buy them in 10 packs. So if you guys ever need a small bit, let me know and I'll sell you one. If you need one right away or whatever.
Sounds like a good idea to go on the vending machine.
Yeah, I actually talked to him about putting them in the machine, and I was going to make little blocks to put them in and whatnot, but I just haven't gotten around to it. But yeah, that's where I get all my bits. And those are your basic bit types. You're going to find other specialty bits. And as far as normal router bits, you can use any normal router bit that does not have a bearing on it.
I would think.
Even if you're going around the edge, you're not going to be exactly sure that, yeah. Just
No. The machine's going to do a way better job on that bearing anyway.
yeah, exactly. So if it doesn't have a bearing on it, then it should be fine.
Were you about to say I would think most people would know that?
I was, and then I was like,
There's a lot of dumb people in the world.
We've got collets for 1/8", 1/4", 3/8", and half. So we got the basic. If you're going to buy a set of collets, don't buy the set that's got 40 different sizes, because you're only going to use 3 sizes.
Well, even Shopbot's website only has the 3 main sizes.
Yeah. But if you go on eBay, you'll see these sets. It's like, 40 collets. It's like, but who's going to use 7/16" collet?
You only need those if you're going into the machine shop and making
Right.
your own tools.
Or if you're buying metric bits, you want to buy metric collets.
Right.
But actually, an 1/8 is close enough to 3 millimeters.
Do you know what kind Carl uses on wax?
Hmm.
Do you know what kind of bits he's been using? Or
I try to.
I'll ask.
Yeah, I try to stay away when he's cutting.
Cutting wax.
Okay. Now,
Does it cut wax to cast or?
stuff looks good. He's just spent 12 hours doing a cut.
Yeah.
He doesn't really need to spend 12 hours.
There's different ways of doing different things.
Feeds and speeds. How fast do you cut? How fast do you spin the bit? That's the science. This right here is our tool database right here. So, as a particular bit should go, I'm gonna say, I don't know. Bits because they publish their chip load numbers for different materials. You're using a Chinese knockoff, you pretty much have to make a guess. And like I was saying when we were in there, you'll know it by the sound it makes. It should sound like it's cutting.
Not like it's.
Yeah. But On the sheet here, I give you some good starting points. Wood, I always use between 12,000 and 14,000 RPMs. And I found that plastic, like the PVC, cuts good at 16,000 or 18,000. And that's the spindle speed that's obviously it's spinning around. Now how fast do we push it through? Now this is something that's very counterintuitive. You're worried about breaking a bit. You're just as likely to break a bit by going too slow than going too fast. Because you might be trying to push it through and it's not cutting enough, you know, you're pushing it through, you know. So it makes no sense, but if you stop and think about it, yeah, it's going slower, it's gonna have more torque, you know. It's like you can hit a ruler against a wall like that all day long and it's not gonna break. Well, take that same ruler and push it slowly against the wall and you can break it. So you can break a bit by going too fast, you can break a bit by going too slow. Basically what it boils down to. And this is our tool info. And the database that you guys has basic tools that I set the speed and feed conservative numbers so that you're not breaking bits. But when you get to this page, this is your diameter of the bit. So this is 0.06. Actually, let's use a bit that's like a 1/4 inch or something. Yeah. So that's a 1/4 inch bit, so it's 0.25. Your pass depth is 0.25, so each pass it's going to go 0.25, a maximum of 0.25. Our step over is like when it's clearing out, it's going to overlap 40%. And 40% is about standard, except for ball nose, you want to go about 9 or 10% because you want to get the detail. But 40% for, you know, clearing out is about what you want. Okay. Wood, I usually go 14,000 RPMs, maybe 12,000 RPMs. The feed rate, that's the part that you don't know. Always figure wood, MDF, plastic, well, not plastic, wood, MDF, plywood, 12 to 14,000 RPMs. But you don't know what speed. And I'm going to go through that right now. Let's bring up Mr. Calculator. Well, actually, I'm going to bring up the Amstrad catalog to show you how to do it the right way. Actually, everyone follow along with me because I don't think you guys have the 1/8 inch O-flute bit on yours. So tell me if your full database has an 1/8 inch O-flute plastic.
It's got the ball nose and the straight.
Under plastic?
Yeah.
Yeah.
Yeah. Yeah, okay. Cool. So what we'll do is we'll add this and we'll figure out the feeding speed for it using the Amstrad catalog and the math. Okay? So we want to go here, let's click new. Bit type is going to be an end mill. And go 1/9 inch O-flute. Okay, and you can put notes like when I set up a bit, like these here, I'll put like the color in the notes so that I know it's one of the red ones. Diameter is 0.125. And how deep should we go per pass? 0.125. That is 1/8 of an inch. And 40% overlap is fine.
But if it's a bulldozer, it'd be 9%.
What?
If
Right. Yeah, 10% of it's polymer. Spindle speed, we're cutting plastic, so let's go 16,000. Because I know that 16,000 is good for plastic. And that should be on your sheet. And now we need to know the feed rate, okay? So here's what I'm going to do. You go to the Onsrod catalog, you go all the way down to the bottom. It's going to have charts for different materials. There we go. Softwood, we're going to be cutting through plastic. So you scroll down until we find plastic. There's soft plastic and hard plastic. See, they got all kinds of materials. Okay, soft plastic. Technically, this is soft plastic, but I use hard plastic numbers on this, and it seems to work out fine. Okay, now, this bit that we're going to be using, where'd it go?
I think it's around on the other side of your.
Tape.
Blue film.
Yeah.
No, they're all those. This is it right here. This is the 1/8" oak flute. So what we do is we look at the number. This is 63,713, 1/8". We're going to be cutting hard plastic. Okay, so let's come up to here. So this is what did I say, a 63?
713.
So we go to the 63-7 series, which is 62, 63. Okay, this is 63-7 series, right? And this is 1/8" here, right? Yeah, it's 1/8" here. So our chip load for this material and this bit is 0.006, between 0.006 and 0.008. Okay? Now let's pull up the calculator and we do some quick math here. Where's the calculator? Is it on there? Oh, yeah, there it is. Oops, hang on. Try this again. My eyes suck. Okay. We know our spindle speed is going to be 16,000. We type in 16,000 times the number of flutes. Since this is a single flute, oak flute bit, we multiply it by 1. Most bits you're going to be using, like for wood, are going to be 2 flute, so you'd multiply it by 2. But we're going to multiply it by 1 times 1, which of course is going to come out 16. Okay? But if you're doing a 2 flute bit, this would be double that. Okay? Then we're going to multiply it by times 0.005, which is halfway in between here.
7.
Or 0.07, I'm sorry.
Just hit backspace.
0.007 is right in between. We're going to come out to 112. This is your inches per minute. Shopbot guys always like to talk in inches per second, so we'll divide this by 60 to get inches per second. 1.86666. So now, if you know 2 of the parameters, you can always get the other one. So, what was our calculation? 1.86? 1.86 is a nice, safe speed for this bit. You could probably go a little faster. If we went on the high end of there, it's 16,000 times 0.008 equals. You could go up to 2.1. Probably push it up to 2.5, but 2.1, 2.13 is safe. And so now we know. What do you do if it's not an Onsrod bit? You kind of look in the catalog. And
Yeah.
what I do is I look in the Onsrod catalog and go, yeah, that looks like, you know, a cheap Chinese knockoff of this one, you know. That's how we figure that out. Everyone following along?
Is 2 kind of the standard? I mean, that's what came up with the feed rate?
What?
Does 2 automatically come up on a lot of the other ones? Is that
One thing you do have to know about the software, and I try to tell this to every class. Anything you change in the software becomes the default for the next time you use it.
Oh.
Okay? So let's say, for example, I go into here and, you know, I go in and change this to, you know, 500 inches per second, which is way too fast for that bit. I hit OK. Okay. The next time someone comes in here, okay, which bit was that? It chooses it. Look, it's 500 inches per second. So if you're doing any design work on these machines, double and triple check everything, because people set things to weird, you know.
So because we're bringing our software, it's using the database here. So even if we had it set in our test software, once we bring it here and open it up in that, it's actually using the software here's database.
Well, pretty much all you're going to be doing here is outputting your cut files here.
Okay.
It shouldn't really matter because your design will be all done by then, and you're just, you know, outputting the final cut files. So. That is how we set our feeds and speeds.
And the plunge rate on that?
Plunge rate is kind of a guess. I usually use the default of like what, 1?
Okay, because mine's at 0.
Oh yeah, well then it's not going to plunge at all. So your plunge rate, yeah, 1 second. That's the speed that it goes down in. Yeah, 1 second is usually pretty good. Something else you need to know. So this tool number, okay, cannot be anything higher than 19, or the machine will crash. And that's because everything over 19, it's set for automatic tool changers and this and that, and it's basically tool numbers higher than 19 are meant for stuff that we don't have. And there's a way to fix that in the software. I'm just not around to fixing it. So just make sure, because if you use the tool database that's in there, some of them might have numbers that are like, see the 30. That's not going to work. And try to make your tool numbers different for each tool. Like, you know, your 1/4 inch feed one number and your 1/8 inch another number, because it can get confused if you use the same number for 2 bits for two different sizes. But that's that. Any questions? Anything that anyone wants to?
Overall, I mean, do you really use all those different bits? I mean, as far as, do people normally have like five
No,
core
I
bits
don't
they use?
actually.
Yeah.
I use the V bit. I use the down cut. I use an up cut. I use the 1/4 inch O flute, which is this one, and I use my 1/8 inch O flute. And I use the V bit quite a bit, and I sometimes use the compression bit to cut plywood, but like, you know, the ball nose only if I'm cutting like, you know, relief cuts.
What's the O flute typically used for?
Plastic.
Plastic.
Yeah, the reason it's a single cutting head is if you use 2 cutting heads, it overheats the plastic and
Melts.
the
Yeah, that's what I
cutting.
figured.
Winter Garden on YouTube. He's building that Marble Machine X, and he's using this plastic. And to get the timings right, he went through something like, he would do a 12-hour cut on this plastic, and then all his pieces would fit perfectly. He's like, awesome. And then he'd come back the next day, and his plastic had shrunk.
Ooh.
Because the CNC was heating up the plastic, causing it to expand. And he actually had to, the developers of not Fusion.
The stool here. I'm gonna, let's see, it's with okay. I'm gonna cut, a hole that I'm gonna put a piece of wood in, fitting stuff like that. First of all, if your wood is 0.75, which it never is exactly 0.75, but say it's measures as 0.71, you want to give it a little bit because it'll never go through. You can make the hole a little bit bigger. Then if I try to cut and stick a piece through like this, it's not going to work. Here's what we're going to get. Let's cut this with let's pocket this out with a 0.125. Zoom in, you'll notice, see the curved corners? You can, how do you cut a square hole on a CNC?
You don't.
You don't. You can't.
You don't.
Even if you use this tiny bit, it's still going to be rounded just a little bit. So what we do in a case like this is we use what are called dog bones or fillets, which is, there we go. This is the fillet tool. So this is, what size bit do we use on this?
1/8.
It's an 1/8 inch, okay. Actually, let's do it with a 1/4 inch, just so we can see it better. Yeah, no, I suck. Okay, so we're gonna cut with a 1/4 inch. Just to make it more profile on what's going on here. Okay, so now we're going to use our fillet tools. Okay, and it's going to ask for the radius of the bit, which is not the diameter. It asks for the radius and not the diameter. I don't know why. In this particular screen, they ask for the radius. So it's a 1/4 inch bit, so we have to half that, which is 0.125. Okay, and you can So your normal fillet is going to be like that, which is opposite of what we want. So you can do a dog bone, which is going to be like that. So you're going to have a little bit of area that's going to show, and you try and place it on the right sides so that it doesn't show as much as possible. You click on it here. The dog bone's always going to be on the corner. You can, let me take this off. Use a T-bone, and you got to be kind of creative with where you place these. You can, place it there. If it's going to be covered up more, but placing it there. But you just kind of have to be creative. The board's going to, cover it up there and put it there. But as you see, Now a board will fit in there. No, it's, you know, you're gonna have those little extra areas, but otherwise your wood's just not gonna fit. And always oversize it. People think that, oh, it's, you know, I'm using 0.75 inch PVC, I'm gonna cut 0.75 inch hole. Gotta go a little bit bigger.
That's yeah, the carpentry will teach you that real quick.
Yeah.
Because you always end up leaning out your hole a little bit with your drill bit.
Right. So that's that. We went over importing. Let me go through some quick import the bitmap. And let's go to our desktop. Maps. Okay. So this is a photograph or a graphic. The better quality art that you have, the better it's going to trace. So, you know, you got a little bitty JPEG. This JPEG all the hell is not going to trace very well. This is a good quality image. Then we've got our trace tool here. And then you get a bunch of options. And I just usually fiddle around with these until it looks right. Oops. Oh, we got to select some colors. Preview. We got that. Let's get some browns in there. Let's bring this down. That looks about right. So now, it's just traced it. Now, of course, you know, when you get into details like that, it's going to be sloppy. And depending on the image that you've got, you're going to have to go in and clean it up.
Okay, wrong direction. Now if it's counted as part, it's already.
Oh, it's
It's
part of the group. So we're going to control U to ungroup. There we go. Now you can get fancy. This is your node edit tool. You could actually go in and, you know, if it didn't do it clean, you're gonna go in and clean these up. Then there's one that I came across that I use a lot since I found it. Okay, see all those nodes? I'm gonna use this guy right here. And it's gonna reduce the number of nodes. Now look, if we go through here, select this, there's a whole lot fewer nodes. And we'll do it again. Nodes. And this. See how many fewer nodes there are? And it still gets the basic shape, and it makes it easier to tweak. But the basic rule is use artwork that's decent, and you'll get decent vectors out of it. But that's it for today.
Is there a way to put a grid behind that?
Yes. Yeah, I'll go through that since we got time.
Sorry.
Under edit,
Talking about grid like a guide.
Yeah, so you can see where you're.
Can't you just drag down from the rulers?
Well, want to grid behind, like the Indian, where they grid behind it, so I can see where, you know, if I wanted to go out on one side.
It's over here. It's I think it's under snap options because there's a grid. So it'll show it as dots.
Okay.
And if you're familiar with software like this, there's different snaps. So like, you know, if I pick it up and move it, it will snap to the closest dot, or you can set it to snap to the closest guideline. So if you get close enough to a guideline, it's going to kind of like magnetic snap up to it. Okay, I'm going to just do something real quick here. We'll now, let's go back and select this all here. Okay, now I'm going to go and I want to cut this out as a pocket, right? Okay, let's go 0.125 deep pocket. Calculate. It's ignoring open vectors. So that's all I'm going to get. Why? Because this is not a closed vector. I intentionally went in and made it not a closed vector. So it can't do this. So what you do, you could either, you've got two choices here, okay? I could go through one by one and find where it's not connected. I know it's there, but you know, something like this can take you forever. So what you do, you select the whole thing. Let's just select it all. Let's select everything on here. Okay, we go up to here, we go up to edit and join vectors. And you've got a tolerance in here, and you set it something really high. And it's going to go through and find vectors that are close enough but not connected and connect them automatically. So see, it's right now you've got closed 22, open 0 when it's done. So we're going to go join. And now we go back and try and cut this. Try the same thing. Oops. Same exact cut as we did earlier. Close there. Vectors up. I know I must be forgetting something because class usually takes longer than this. Okay.
Well, 3 out of 4 of your people here are really good.
And he's filming, so that'll help a lot.
Yes.
Question I get asked a lot is, how long is this going to take to cut? Got our little timer thingy jig here. We go there. And I found that if you set your rapid rate at 5 and your scale factor at 3.8, which I did put on here, okay, it's going to get you damn close. So let's I have my thumb drive in there. Hang on, I'm going to go grab my thumb drive. You just cut. the one we just cut. How long do you think that, how long would you say that took? 15 minutes maybe? Maybe a little bit longer? So this is telling us it's 24 minutes, which is about right, about 13 minutes for the first one, about 10 minutes for the second one. It's never gonna be within seconds, but it's gonna be within minutes.
Yeah.
We'll just say it's gonna be a lot closer than the estimate for the 3D printer. It's gonna be, you know, within 10% maybe. It'll give you a good. It's something we gotta play with quite a bit. Okay, let's go. What's our longest dimension here? There we go. Rotate the way you want it. Rotate this way. This takes quite a bit of playing around.
Was that an STL?
I think it's an OBJ. I think that's fine. This is fine. So let's see. Put this to where we can see it here. Looks pretty close. And let's make this way just a little bit. Is this the right one? We'll bring it down into the tree a little bit. Yeah, that's close enough to show you how to do it. But you just have to, you know, play around with it.
So, with what you were doing there, you could actually take each one of those layers. Am I understanding correctly? You could like route each one of those layers as it goes through the skull. You can move the skull up and route it,
Well,
and then
I'll show
actually.
you how to-
I'm not sure what you were trying to do there. Were you just trying to put?
Doing a relief.
Okay, we'll do a relief. Now it's, if you, when we looked at it, it was taller than my material.
Uh-huh.
So if you go here, you're gonna set, and then you can hit set here, and we say we want our model height to be 0.5 inches, and it's gonna kind of scrunch it down. But it's still will look pretty good. And we want our gap above the model or below the model. Or we want the gap above the model. So like that's going to be a base, and then it's going to cut out all this here.
Oh, okay.
So now it's doing position to Z. So that's what we got.
Oh, okay.
So now, the way we would cut something like this is we would first do a rough path. which is going to be with the standard normal bit. Let's say a 1/4 inch end mill, and we want to go to the, let's say material boundary. Okay, so that's going to cut all of this out. Okay. Let's go wood. That's what the first one's going to cut out. That's your roughing pass. And sometimes when you do a roughing pass, you might want to, you know, set it to do, you know, less deep of passes. Or you might want to set your, you know, your stuff over. But it looks pretty good for what we got here. So let's see. I don't know why this keeps jumping off my wood. Okay. And then, once we got that, then we go in with our finish tool path, which is, this is going to be the ball nose, right? We're going to, so this is a 0.125, so this is an 1/8 inch ball nose. I don't know why this went deeper on this one.
Have you done this particular design?
Yeah, I have actually. They take forever.
So what's the expected runtime on that one?
Well, let's find out. Expected runtime is 2 hours for the roughing and 2 hours for the finish.
Wow.
So it's a 4-hour cut.
What's the,
The roughing is taking a lot of time because it's cutting out all the stuff around it.
what was the dimension of it?
It's
I
like
think it was a
5
half
inches.
inch tall.
Yeah, 5 inch.
And then the finish one, you know, just goes through it like 10%, you know, it's just back and forth, back and forth.
Now, you could save a lot of time by going to like a 1/2 inch
Yeah.
end mill, right?
Right. Well, you'd save a lot of time by, see, if I was actually gonna do this, here's what I would do. I would select this, and then there's a tool in here under modeling that will basically give me a vector of around it, right? What I would do is I would do this, and then I would take this, and I would this, and then say this. I would just cut a normal pocket of all the material off. Like a 1/4 inch or whatever. Oops. Oops, okay. Which one? Oh, this is the one I wanted. So I would do something like that. And then when I did this one, I'll just go to the model boundary. And that should speed things up because now it's only going through here. So now if we look at their see that that's going to take 19 minutes and then a minute, which you could probably even leave this step out. And then we're down to 12 minutes for our roughing and 2 hours for the finish. So we just cut 2 hours off. Because when it does the roughing toolpath, it's going back and forth at 10% overlap, you know, or whatever, you know. But, and what I usually do when I'm got a bunch of stuff and I'm cutting, I try to, where possible, put all my same bits together. You know, if you got all your 1/4 inch, put all your 1/4 inch there. If you can, sometimes it's not feasible and you can't really do it. But if it's possible, put all your 1/4 inches together. Because when you output a cut file, you've got 2 choices. You can output everything into one file, and then you have one cut file, and the machine will stop and tell you to change the bit. Or you can output them as separate files. But even if you output separate files, I try to put like all my 1/4 inch together in one toolpath file, and like